This is a graphic LCD module. I'm holding the reset button down. I'm going to let it go now. So this is a type of module. It's called a 128 64B version 2.0. Typically used with the STC microcontrollers that modern 8051 derivatives, but here I've hooked it up to an Arduino Nano to try it out. So it's called a 12864B version 2.0. It's 128 pixel by 64 pixel graphics. You can see it can do text as well. It's also capable of doing Chinese or Japanese, Korean characters, but I don't understand those. But it's got a character generator to do those as well. I'll just start the demo going off again by pressing the reset button, and I'll explain what's happening. So it just it draws the text. It starts drawing this ring, moving over the text. And it starts off with it going very slowly with a delay, so you can see what's happening, and the delay slowly gets smaller and smaller until in the end it's going as fast as it can. And the drawing the ring is I think it's 88 pixels it's having to draw, and it's drawing it twice in using the XOR mode to rub it out, and it's doing double buffering. This display has got enough RAM, both sort of character RAM and graphics RAM, to hold 2 screenfuls worth of data, so you can double buffer it, which stops you seeing some of the glitches that you otherwise see on the display while it's being redrawn. So it draws to an off-screen area and then flicks that into view while it's drawing the next screen off-screen again, if you see what I mean. So here I'm using the 8-bit data bus. You can do either 8 or 4-bit parallel data bus. The 8's obviously faster. In addition, you need 3 control lines, sort of read-write line, one that selects either the registers or the RAM, and one as a sort of clock strobe. You can also, so that's 11 lines if you're using an 8-bit data bus, which is what I've got here, or you can do 7 lines if you go for the 4-bit data bus. Obviously slower because it's got to do twice as many reads and writes to get the same data through. It can also, this display, do SPI, where it only uses 2 lines, a sort of data and clock, plus a chip select line if you want to use anything else on those same SPI lines. But in that mode the display is write only, which makes graphics a lot more difficult unless you've got a microcontroller that's got plenty of RAM, where you can hold a graphics buffer inside the micro. But here it's just using the display itself as a graphics buffer. So whenever it's drawing this ring, it's having to read the pixels from the display, flip the appropriate pixels to move the ring, and then write them back again. I've connected it up with a data bus going from pin 2 through to pin 9, and then I'm using 10, 11 and 12 as the 3 control lines. I've got a resistor in line with the backlight. That's a 470 ohm resistor to limit the backlight current. Not using a contrast adjustment pot because there's one on the back of the the board itself. You see that little contrast pot there. By altering some links on the back of the board, you can use an external contrast pot if you want. Okay, that's about it. Details and code in the link.